Students, welcome to the next lesson in our bivariate data and linear topic. This session or this lesson is going to be focusing on the linear part of our topic. So last lesson we finished up on chapter 9F, 9G, where we did scatter plots for 9G and how we can use scatter plots and lines of best fits to make predictions. Now, this chapter is sort of a breakaway from that. However, you'll find out later on how it all ties in together. So for today's lesson, we're focusing on solving linear equations. So our intention is to solve linear equations by preserving equivalence. Okay, there's a keyword there, equivalence. You can probably make an assumption of what that word means with the first part here, equal or equivalence. Now, equal meaning it's equal on both sides, okay? And as our success criteria, you'll know how to find the unknown variable. Generally, when we do this topic for linear equations and solving them, the unknown variable is normally x. Okay, you'll find that that's normally the case, but it can be other letters as well, all right? But normally we'll refer to it as x. You can present situations using linear equations, so reading a scenario and then using a linear equation to solve it. Identify the sequential order, okay, so finding the order of doing the operations to find that unknown variable. All right, so there's a step-by-step process that you need to follow to solve an equation, and you can solve an equation using some of the techniques and little tricks that we use to find the unknown variables, so such as inverse operations, brackets, and expanding them, and also variables on both sides. So having unknown variables on both sides of this equation. All right. So normally when you see the word equation or equivalence, there's an equal sign involved. Okay. All right. So as a starter activity, let's look at this. So Philip Fitter exercised each weekday. With them bulging muscles, lovely. Okay. On Monday he did 4 chin-ups. Tuesday he did 5. Wednesday he did 5, and then Thursday he did 15. How many chin-ups did he do on Friday if his average mean for the first 5-day week was 8 chin-ups per day? So this sounds a bit complicated, okay, but have a think about how you could try and solve this given the information you have already. So you remember this is the number of chin-ups he did every day, and he did an average of 8 per day over a 5-day week. Okay, and we're trying to figure out how much could he have done on Friday. So, as a solution, there's 2 ways you could go about this. You could work backwards, okay, by finding the average chin-ups over the 5 days. So, if he did 8 chin-ups per day, so remember the question on average, right? 8 chin-ups per day average. And there were 5 days. In total, there should be 40, supposedly 40 chin-ups in that total of Monday, Tuesday, Wednesday, Thursday, Friday. So, from Monday to Thursday, he did 29 chin-ups. So what we can do is we can actually minus the total that he should have done, take away everything from Monday to Thursday. And this, a number, 11, should tell us how much he does on the Friday. Because if he does a total of 40 and he's already done 29, okay, that means 40 take away 29 should be 11 on the Friday. Because, Monday to Tuesday he did 29. The other way we can do this is algebraically. Now, this is a bit confusing for now, and it may not make sense just yet. But just hear me out. Let x be the number of chin-ups on Friday. So remember, we're going to use x as that unknown variable. So we're trying to figure out what is x. Okay, we know that he's done 29 chin-ups already. So from Monday to Thursday, he did 29, yeah? So that means this unknown value plus 29 should equal something. And then to find the average, you have to divide by 5 days. So remember, average over the 5 days. Normally, if you want to find the average, you've got to divide by how many days there were. So in this case, there was 5. So in terms of representing this whole scenario as an equation, it should look like this. Okay, x plus 29 over 5 equals 8. And then if we wanted to solve it, now again, this is going ahead a little bit. Oops. It's already there, sorry. Going ahead a little bit, but to solve it, get that 5, okay, gets moved here, becomes times. Okay, and then you're left with x plus 29 equals 40, and then from there, get that 29 becomes a minus 29, so you're left with x equals 11. So, same answer. All right, now with that said, again, it may not make sense now, but let's go through the lesson, or at least watch the lesson so that you'll understand what we're getting at. As we know, in data, bivariate data in particular, okay, it involved two types of variables, which are usually somehow related. So if you remember back to data, you'll know, or bivariate data, remember you'll have a scatter plot and you'll have an x variable and some sort of y variable, and you might have a scatter plot that looks like this, okay? And we know, remember, we know that if they're linear like this, or if there's some sort of strength and direction, that there's a correlation and they're somehow related, okay? And you can see here that there is a relationship between x and y, yeah, because it's going in a direction. If there was no relationship like this, for example, like that, okay, then we can't apply linear to it, because linear, okay, means straight line. So you can't put a straight line through that. Okay. And the primary purpose of the bivariate data is to compare two sets of data or finding a relationship. Remember, that's what we sort of did in 9F and 9G. The relationship between two variables can be described as linear or non-linear. Okay, so we're focusing on linear. Non-linear is what I just drew here. So this is non-linear. If you just draw a little graph there. So that's non-linear there. Okay. We're focusing on linear. So a linear relationship exists between two variables in the graph if the relationship is a linear, so a straight line. So if you can put a straight line, let me see if I can make this more obvious. So if you can put a straight line, like a line of best fit into the graph, okay, then that indicates that there is some sort of relationship. Okay. A linear relationship can be represented by a linear equation. If we know the value of one of the variables, we can solve the equation and find the corresponding value of other variables. So what this is saying is you can actually find the unknowns, whatever they might be, if you know, okay, the value of one of them, one of the variables. So generally, and this is again going ahead a little bit, if you have an equation that's like y equals 2x plus c, if you know one of these, so let's say if you know what y is and you change it to, let's say 5, so let's change this to 7, okay, then you can solve this equation, okay, because there's only one unknown, okay. If there were two unknowns like this, then you can't solve it, okay. But you need to at least know one of the variables. The purpose of solving this equation is to find the value of a variable, okay, so you're trying to find out what that unknown is. Remember, the unknown I'm going to refer to a lot as x. That makes the equation true. This means that one side of the equation is equal to the other. So remember that first word we saw, the equivalence, the x, the equal sign, yeah? So what this is saying is what the point that we're trying to get to is trying to find out what this unknown is going to be. Now it could be x equals 7, x equals 10, x equals 4.5, whatever it might be, but that's the whole point, is trying to figure out what is this unknown, or this unknown. Okay, so it could be like x equals 2. Okay. All right, let's go through some skills that you'll need to use to be able to do what we just talked about. So the following skills are drawn upon when you're solving your equation. So you need to know how to simplify by collecting like terms, adding and subtracting. Okay, so in a quick nutshell, collecting like terms, okay, is the main thing there. So you can add and subtract like terms. The other thing is collecting like terms by multiplying and dividing. So you can add and subtract, and you can multiply and divide, okay, with your like terms. Now, there's different rules for each one, slightly different ones. We'll go through them as we go through the lesson. And then last one is expanding your brackets. So pretty straightforward. The idea behind expanding the brackets is trying to get rid of the brackets by generally multiplying. So let's look at some of these skills before we actually start solving some equations. So let's start by simplifying like terms by adding and subtracting. Okay, so the best way to sort of understand what a like term is, okay, is when their variables and their exponents, such as 2 and x squared, okay, are exactly the same. So they have to be exactly the same. Now, when we talk about the variables, I'm talking about the letters. Okay, so when you look at a letter like this, okay, when you have a term, so a term is basically, for example, 2. Okay, or let's give you, actually, let's try this. So let's say you have 3x plus 5. That's a term. That's a term, okay? Or if I have like 2y plus z take away v. That's a term, that's a term, that's a term. Okay, that's what a term is. And an exponent, or a variable is basically, let's say you have 2x squared plus 3. That's a variable, okay? Or if you have 4y plus 2z, that's a variable, that's a variable. And one more thing that you need to know is a number by itself, it's called a constant. All right, number by itself is called a constant. Okay, so going back to this, in order to simplify a like term by adding and subtracting, they have to have exactly the same variables. Okay, to help with collecting like terms, it's also important that you rearrange the equation. Okay, rearrange the expression, sorry, and it helps to do that by putting the like terms together. Another thing to make note is the operator. Okay, the operator is the number in front of the term. So let's say you have, again, 2x minus 2y plus 4z take away 2y. Okay, the operator for 2x is plus because there's nothing in front of it. The operator for 2y is minus because there's a minus in front of it. The operator for 4z is plus because there's a plus in front of it, and same with 2y. There's a minus there. Okay, so you want to make sure you group the term together with the operator, like so. Okay. So let's see this example here. Let's try and group the like terms for this. So remember, the like terms, you want to make sure have the same exact letters and the same exact exponents. Okay, so that's an x squared. The two, if you want to group a like term, they have to have exactly the same squared or x squared in there. But in this case, there's no exponent, so let's get into it. In this case, I can see that the like terms, okay, and what I've done here is I've grouped them together because I've recognized that 2x and 1x plus 1x are exactly the same. And the other terms that are the same as well here are 11y and negative 6y. Okay, so what we've done is we've put them together. As you can see, okay, 2x and 1x have been put together here. And then you've got 11y and negative 6y there together. All right, so solving that, just put them together. 2x plus 1x equals 3x. 11y minus 6y equals 5y. Easy. Example 2, now we've got some exponents here. So remember, it has to have exactly the same letters and the same exponents. So in this case, make sure you double check and see what you have here. It doesn't matter what order they're in here. Doesn't matter, because as long as they have the same exact letters and the exponents on the top right for each variable. So in this case, I can group 3xy squared and negative 5y squared x. Okay, so I'll put this one and this one together. See? And then 2xy can just be by itself. All by itself. Don't know if anyone got that reference. But anyway, now we put the like terms together. So 3xy squared take away 5y squared x. So it's basically 3 take away 5. So it's negative 2xy squared plus 2xy. So if I was to, in a nutshell, or make this all a bit simpler for you, you're just adding and subtracting basically the numbers in front. Okay? You're just adding and subtracting the numbers. But of the letters that have exactly the same letters and exponents. Okay, that's kind of the simple way of understanding what it's like to collect like terms. And this is for adding and subtracting there, okay? Slightly different rules when it comes to multiplying. Okay, so when you multiply, you need to multiply or divide. Oh, I forgot to tell you, the coefficient is the name of that number in front of the letters. And then multiply or divide the variable by applying the index laws. Okay, so don't get too scared of this. I'll explain it as we go with these questions. All right. So when you multiply or divide your like terms, the idea is they actually all group together at the end. Slightly different too. Adding and subtracting where they don't go together. Okay, they're sort of are still separate because the variables are different. But when it comes to multiplying, you end up getting all of these sort of coupled together. So let's start by, in this case, what they've done here is they've gone 2 times x, so they've actually broken it up, and then 4 times x times y. Now, there are simpler ways to do this, and I'll go through that in a second, but basically what happens is you got to multiply the numbers together, and then you put together all of the letters. Okay, so that means 2 times 4, we get 8. Okay, right there. And then x times x, you get, there's 2 x's there, so it becomes x squared. And y is just by itself. Okay, so there's no more y, just by itself. So if I wanted to simplify this myself, you don't actually have to do this, but if it helps, please do it. Okay, all you can do is simply 2 times multiply the numbers together. So 2 times 4, you get 8. You see there's an x there, there's an x squared, there's x and x, so that means when you multiply them together, you get an x squared, and then there's a y by itself. Alright, and you get the same answer. This one's a bit different, or a little bit trickier, okay? Because now we're dividing. Remember what this line means. It means divide. So when you're dividing, it's slightly different too, obviously, when you're multiplying. When you divide, start off by dividing the 10 and the 2, but watch how it's breaking it down here. So the 10 and the 2 get divided. Actually, let me not do that because it might get a bit confusing. So divide these two basically. When you try to divide them, what happens is obviously you got to think about what's the common number that you can divide them both by. In this case, it's 2. Okay, we'll keep it simple. So they basically cancel each other out. That becomes 1, and that becomes 5. So you're left with 5a over 1ab. Now, when you get a 1, you actually don't need to keep it in there anymore. So you're just left with 5a over ab. Okay, now the next thing to do from here, okay, is what else can you divide? Well, in this case, a and a can be divided. Okay, and when you're dividing, you're actually subtracting from each other. So if you have a, take away a, what are you left with? You're left with 5 over b, because all the a's are gone. Okay, now I'm hoping this one here does take a bit of time to get used to. I might just do one more example before we move on. So let's say you have 6ac over, let's go with 3a squared d. Okay, so in this case, or in this scenario, what we'll do is let's divide the numbers first. So you're left with that 3 and that 6. Well, they divide into each other. That becomes 2. Okay, the a, okay, notice how there's an a up here, but there's an a squared here. You're just minusing them. So a2, take away the a1 there, so you're left with just the a on the bottom because the a on the top is gone, and then you've got a c and you've got a d because you can't divide them by each other. I'll go through more examples later on for this. Okay, the last thing is expanding your brackets, or the distributive law. So brackets are used to change the order of operations, and they allow addition and subtraction to be done before multiplying and division. Okay, so that's something interesting that you need to remember. When you expand the brackets, it allows you to change some of the orders and do subtraction and multiplication to be done before multiplication. So we can rewrite expressions using without brackets if we multiply every term on the inside with what's on the outside. So what's that? What this is saying is basically when you're expanding brackets, you're multiplying all the numbers on the outside with the numbers that are inside. Okay, so 2 times 2, 2 times 4. Okay, now let's go through some examples. So example 1, 2x plus 4. So what happens here, you're multiplying the 2 with the x and the 2 with the 4. And you're left with 2x plus 2 times 4. So you go 2 times x, which gives you 2x, and then 2 times 4, which gives you 8. So your answer is 2x plus 8. Now, this might get a bit confusing for some of you guys, but it is a bit different when you have a minus. Okay, remember what happens when you're multiplying with a minus or with a negative. Okay, if you multiply a negative with a positive, it stays negative. A negative with a negative, it becomes a positive. So let's try this out. So 3x, negative 3x times the x, and then negative 3x times the negative y. Now you don't have to again break it down like this, okay, as it can get a bit confusing. So the answer for this one is negative 3x squared plus 3xy. But I will actually, without the working out, show you how to do this really easily. So remember, you're just multiplying this with this. So negative 3x times x. So negative 3 times, there's no number in front, so just assume there's a 1, so you get negative 3. And then x times x squared, x times x. So remember, when you're multiplying letters, they get added together. So you get x squared. Okay, the next thing is negative 3x times the negative y. So negative 3 times, remember, in front of here, there's a negative 1. So negative 3 times negative 1 gives you positive 3. X and y you can't multiply, so you're just left with x, y. Okay, so again, you don't have to break it down into this. If it's easier for you to do it this way, please do so. Third example, all right, so this one, again, I'll break it down here for you guys, and then we'll go through it. So 3 times x, let's do this one first. Okay, 3 times x gives you 3x. So what I've done is number on the outside with the number on the inside. And then 3 times 2 to positive 2, it gives you 6, so plus 6. Easy. Next one, negative 4 times 2x. Okay, so negative 4 times 2 gives you negative 8. Oops. And then you've got the, there's nothing, no letters to multiply, so you just leave it as x. Negative 4 times negative 4 gives you positive 16. Okay, that's where I got, that's where that is. Okay, and then from there, the last thing is to put the like terms together. So run out a bit of space, but basically what you can do, okay, actually what I will do here is I'm just going to underline the like terms. So 3x minus 8x, so put them together. What are you left with? 3x minus 8x is negative 5x. Okay, and the other terms to put together, okay, is your plus 6 and plus 16. So positive 6 plus positive 16 equals plus 22. Positive 22. Oops. All right. So I'll get you guys to try and do the following, and then we'll go through it together as solutions. But if you want to go and try, go for it now, and then I will go ahead and do them for you. Okay, let's try it out. So let's try the first one. So 4a plus 13a. Basically, you're going to simplify them. Okay, so just basically putting the like terms together. So 4a plus 3a. Well, that equals, nice and easy, 4a plus 3a is 7a. Straightforward, right? Nothing too hard about it. Just add the numbers. Next one. Let's use a different color. 5ab squared, so let's put that in here, 5ab squared minus 2ab squared. Okay, nice and easy for this one. Okay, again, just adding or subtracting the big numbers, so the coefficients. So 5 minus 2, you're left with 3ab squared. And the third one here, so 3xy, I need to make it a bit smaller, plus 4x squared, take away xy, plus 2yx squared. So that's a big one, isn't it, guys? Alright, so let's do that one. Put the like terms together. Yes, so I'm gonna underline. Actually, I'll just underline it here. So xy goes with this xy. So if you want to, you can rewrite it and just go 3xy, take away xy. Remember, in front of that letter, there's a magic one that you don't see. And then the other one is plus 4x squared and plus 2yx squared. Even though, oh, actually, yeah, sorry, I forgot to put a y there, hey, my bad. There you go. Alright, so put these together. So you're left with plus 4x squared y plus 2yx squared. So putting them together, alright. Remember, when it comes to adding and subtracting like terms, you're just adding and subtracting the big numbers. So here you get 2xy, and here you get 4 plus 2, okay, gives you 6x squared y. So there's your final answer. Okay, let's try multiplying. Alright, so here, 3a times 3b. So 3a times 3b. Remember, for this, all you're doing is just multiplying the numbers in front. So the big numbers, 3 times 3 is 9. A and B, well, you just put A and B together. Can't multiply them, so there's your final answer, AB. And the next one is negative 2x squared y times 5xy. So negative 2x squared y times 5xy. Okay, and that'll give you negative 2 times 5 equals, so again, with the multiplying and dividing, just multiply, divide the big numbers, and then the little numbers, the little letters, you either add or subtract them. Okay, so negative 2 times 5 is negative 10. X to x squared times x, that means you're adding the little indices on the top. So x squared times x gives you x to the power of 3. And remember, there's little ones up here too, so y times y will give you y squared. Let's try out this one here, 4a squared b over 8a, so negative 4a squared. So in this one, let me do this a bit here. So 4a squared b over 8a. Don't get too scared of that negative. We'll just leave it out for now, and we'll see the final answer. So for these questions, remember, you're just dividing the big numbers, and the little numbers you take, the little indices you take away. So 4 divided by 8, that gives you 1 over 2 for now. But remember, you don't need the ones anymore. So we'll leave that there for now. The a squared and the b, okay, so the a squared and the a. So these a's will cancel one another out in some way. So remember, 2, there's 2 there and there's 1 here. So that a will be gone, but this will just become 1. So you just left with an a. And b, you can't divide with anything because it's on its own. So there's your answer. A over b. Okay, last one, expanding the brackets. Alright, so when it comes to expanding the brackets, remember, you're just multiplying the numbers on the outside with the numbers inside. So you've got 3x plus 2. Okay, number on the outside, multiply with the numbers on the inside. So 3 times x is 3x. And then 3 times 2 is 6 plus 6. That's it. Next one. Okay, you got negative 2x times x minus the y. Okay, let's try that one out. So for this one, it's the number on the outside with the numbers on the inside. So all of this times this guy. Okay, what are you left with? Well, negative 2 times the number in front of x. Remember, in front of that x, there's a magic 1. Negative 2 times 1, negative 2. X times x gives you x squared. Okay, next one is that negative 2x times that negative y, this guy. So negative 2 times in front of there, there's a magic 1 that we don't see. So negative 2 times negative 1 gives you a positive 2. X times y is just xy. There's your answer. Alright, last one. 2 and then x plus 3 minus 3 2x minus 1. Okay, this one might be a bit longer because there is still one final step in the very end to do. Okay, I might actually just rub this off and just use it as is there, guys, because I might need the space. Alright, so for this one, 2 times x, yes, a number on the outside with a number on the inside. So you got 2x and then 2 times 3. Okay, so 2 times 3 is 6 plus 6. Negative 3 times 2. Okay, so negative 3 times 2 is negative 6. And then x you can't multiply with anything, so that's fine. Negative 3 with a negative 1. So negative 3 times negative 1 gives you positive 3. Okay, now this isn't the final step. Yeah, we've got one more thing to do. We've got to add the like term. So this guy here is a like term, and this one here is a like term. So putting them together, 2x minus 6x, you can actually rewrite this if you want to, yeah? You can go 2x minus 6x if you wanted to, but you don't have to. Okay, I'm all about the shortcuts. And then that 6 and that 3 go together. So plus 6 plus 3, 3. Okay, now from there, put them all together, or at least the ones that you can. So 2x minus 6x equals negative 4x. 6 plus 3 will be equal to 9. And there's your final answer. Alright guys, so that's going to be it for this video. I'd like you all to complete these questions so that you can really understand everything that we've just done. And I'm also slowing it down a bit because all of this is really important, because if we want to move on to the next part, we're going to need to be able to, which is solving linear equations. You're gonna need to be really confident with this part. Okay, so obviously you'll notice there's more in the PowerPoint later on, but we're going to stop here, do these questions, so and then we'll go from there. Submit your questions as well so I can say that you're able to do these. Thank you.